everyone, we're going to practice finding rational zeros. Once again, it's just an extension of the last video, of the last lesson. But before we get started, I want you to please go ahead and factor each of these expressions. The first one is 100 squared minus 25, and the second one is 64x cubed plus 1. When you have an answer, go ahead and restart the video, and we'll see how well you did. All right, so for this first problem, hopefully you saw that 100 and the number 25 have a common factor of 25, with your leftovers being 4x squared minus 1. Now 4x squared minus 1 is a difference of two squares, so we're going to break that apart into two parentheses, and that's going to be 2x plus 1 and 2x minus 1. And that is your answer. The next one is a sum of cubes. So the way that we break that down is we use SOPs. We're going to have a binomial times a trinomial. In your binomial, you take the cube root of the first term, and that's going to be 4x. Then you take the cube root of the last term, and that's going to be plus 1. Then you do square opposite product squared. So 4 times 4 is 16, so that's 16x squared. The opposite sign is a minus. Product, 4 times x is 4x, and then square, 1 squared is plus 1. And that is your answer, 4x plus 1 times 16x squared minus 4x plus 1. If you find that factoring is very challenging for you, please make sure that you come and see me after school as soon as you can so that I can help you with factoring. All right, so here are our learning objectives for today. It's just an extension of what we've already learned before. But the I can statement is, I can use the rational zero theorem to identify all possible rational zeros of the polynomial function. Like I said in the last video, it's just possibilities. It doesn't mean that it actually is a rational zero. And then I can use my graphing calculator to identify a rational zero to help me solve polynomial equations. So for this video, you're going to be required to use a graphing calculator. And then finally, it says I can solve real-world problems by solving a polynomial equation. So the first problem that we have for letter A is f of x is equal to 8x to the 4th power plus 2x cubed minus 21x squared minus 7x plus 3. For this problem, it's quartic, and because it is quartic, that means that we're going to have to put this function into our graphing calculator, and we're going to need to identify two reasonable rational zeros. So we're going to have to identify that. Notice that this is not 4 terms. If it was 4 terms, we would try factoring by grouping, but we can't in this case. So the first thing I'm going to do is I'm going to identify all of my possible rational zeros. So that is always going to be step number 1. Identify your possible rational zeros. In this case, the factors of my constant term, which my constant term is the number 3, is going to be plus or minus 1 and plus or minus 3. This is going to be divided by, so these are my p's divided by q's. Divided by, the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So now what I'm going to do is I'm going to divide every single numerator by every single denominator to find all of my possible rational zeros. So that's going to be 1 over 1, which is plus or minus 1, 1 over 2, which is plus or minus 1/2, 1 over 4, which is plus or minus 1/4, and 1 over 8, which is plus or minus 1/8. Then I have 3 over 1, which is plus or minus 3, 3 over 2, which is plus or minus 3/2, 3 over 4, which is plus or minus 3/4, and 3 over 8, which is plus or minus 3/8. So these are all of our possible rational zeros. At least one of these should work, and we should find at least one of those rational zeros in our calculator. But now what we're going to do is we're going to identify our reasonable rational zeros that we identify using a calculator. And because this is a quartic, we're going to have to identify 2 of them. So in my graphing calculator, I'm going to enter in the function 8x to the 4th power plus 2x to the 3rd power minus 21x squared minus 7x plus 3. I'm going to press zoom 6 so I can see my standard screen. And I need to identify 2 rational zeros. So I'm going to press second trace, go down to a 0, press enter, and I'm going to try to identify, I guess, why not this one? Here's an x-intercept. Here's to the left, and I guess I can press enter. I'm going to go to the right, press enter, and then enter. Ooh, that's not a nice number. That's negative 0.618. That's not nice. I don't know what that is. So sometimes, the reason why I did that is because sometimes your 0 is not going to be rational. So that's going to be kind of a clue to tell you that, well, when it comes to our zeros, we're going to have to get a little bit more clever, and we'll have to find something else that'll work because that number is not rational. So I'm going to do this over again and press second trace, and I'm going to try to find what this 0 is, and I'm going to see if it ends up being rational. So it looks like when I press the right arrow, it goes below, and when I press the left arrow, you can't see it anymore. So I'm going to press enter for not seeing the blinker anymore. I'm going to press the right arrow once, and now it's below the x-intercept. So I'm going to press enter and then enter again. Okay, so I found that one of my zeros is negative 1.5. So I'm going to write x is equal to negative 1.5, and I'm going to write that as a fraction. So that's going to be x is equal to negative 3/2. So what parenthesis would produce a negative 3/2? Well, what we can do is we can work backwards and make this equation equal 0. So what I'm going to do is get rid of the fraction by multiplying both sides by 2. And I end up with 2x is equal to negative 3. And I'm going to add 3 to both sides. And I find that 2x plus 3 would be equal to 0. So the parenthesis that this would come from is 2x plus 3. Cool. So now let me go ahead and find another 0. So that's one rational 0. And that is x is equal to negative 3/2. And we can work with that number. It's not a big deal. I'll show you how to do it in just a second. So I'm going to press second trace and go down to number 2, which is a 0. And I'm going to try to find what maybe this 0 is over here. Maybe that'll work. Or maybe this one. I'll try the next one. Let me see what I can come up with. All right, so here's to the left. I'm going to press enter. Here's to the right, enter, enter. And I end up with 0.25. So 0.25, I know what that number is. X equals 0.25. That's equal to 1/4. So we want to figure out what parenthesis 1/4 would come from. So I'm going to multiply both sides by a 4, and I end up with 4x is equal to 1. I'm going to subtract 1 on both sides, and I end up with 4x minus 1 would equal 0. So the parenthesis that x equals 1/4 would come from is the parentheses 4x minus 1. All right, well, let's just verify that we can't find something nicer. So I'm going to go second trace and go down to 0, and I'll try to find what that other 0 is right here. So it looks like this is down here to the left. Enter, to the right, enter, enter. Okay, that is super ugly, so I'm going to say we found all of our rational zeros. All right, so our rational zeros are not numbers that we've worked with before. We've never done synthetic division using fractions, but I'm here to tell you it's really not that big of a deal. So the first thing I'm going to do is I'm going to use negative 3/2, and I'm going to put that inside of the little box, and I'm going to write down 8, 2, negative 21, negative 7, and 3. I'm going to bring down the 8, and negative 3/2 times 8, that is equal to, I believe that's equal to negative 12. And then 2 minus 12, that is negative 10. Negative 3 halves times negative 10, that's equal to 30 over 2, which is 15. Negative 21 plus 15, that's equal to negative 6. Negative 3 halves times negative 6, that's equal to 18 divided by 2, which is 9. Negative 7 plus 9 is 2. Negative 3 halves times 2 is equal to negative 3. 3 minus 3 is 0, which is awesome. I was able to end up with a remainder of 0. So where we're at right now is we have a 2x plus 3 times an 8x cubed minus 10x squared minus 6x plus 2. And that would equal 0. So what that means is I'm going to use this polynomial to use synthetic division again. And I'm going to use synthetic division of this cubic function using the other 0. So I'm going to write 1/4, and I have 8, negative 10, negative 6, and 2. I'm going to bring down the 8. 1/4 times 8 is 2. Negative 10 plus 2 is negative 8. 1/4 times negative 8, that is equal to negative 2. Negative 6 minus 2 is negative 8. 1/4 times negative 8 is negative 2, and 2 minus 2 is 0. Awesome. So I got a remainder of 0, which is exactly what I want. So this is where I'm at so far. So far I have a 2x plus 3. Now I have a 4x minus 1 times 8x squared minus 8x minus 8 equals 0. So 8x squared minus 8x minus 8, this whole trinomial, this quadratic, is all divisible by 8. So I can divide out an 8 and make this 8 times 2x plus 3 times 4x minus 1 times x squared minus x minus 1 equals 0. So the x squared minus x minus 1, I have to figure out what two numbers multiply to equal negative 1, but together add to equal negative 1. So when I put negative 1 and positive 1 in, negative 1 plus 1 is 0. That's not negative 1. So that means that this is not factorable. But that's okay. Whenever you have quadratics that are not factorable, you use the quadratic formula. So we're going to use the quadratic formula. So far I have x is equal to negative 3 halves, and I have x is equal to positive 1/4, and now I'm going to have x is equal to the opposite of b, which is 1, plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. This is all over 2 times a, which is 2 times 1. So now I have x is equal to 1 plus or minus the square root of some number divided by 2. So I'm going to put in negative 1 squared minus 4 times 1 times negative 1. And I end up with the number 5. So these are my 4 solutions. I have 1 plus or minus the square root of 5 over 2. X equals negative 3 halves, and x equals 1/4. That is a total of 4 x-intercepts. And typically, whenever you have an exponent, whatever your exponent is, that represents the maximum number of intercepts you could possibly have. And in this case, we ended up with 4 x-intercepts. All right, we have 2 more examples. If you would like to try example B on your own, I encourage you to do so. And pause the video and then restart it to see how well you did. All right, for this problem, the first thing that we need to do is we need to identify the fact that this is a quartic. So that means we're going to need 2 reasonable rational zeros. But before we do that, we need to identify our possible rational zeros. That's going to be your p's over q's, and your p-values are all the factors of 6, so that's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. This is going to be all over our factors of 9, which are plus or minus 1, plus or minus 3, and plus or minus 9. So I'm going to divide every numerator by every denominator. So 1 over 1 is 1. 1 over 3 is plus or minus 1/3. 1 over 9 is plus or minus 1/9. 2 over 1 is plus or minus 2. 2 over 3 is plus or minus 2/3. 2 over 9 is plus or minus 2/9. 3 over 1 is plus or minus 3. 3 over 3 is 1, and I'm not going to write it again. 3 over 9 is 1/3, and I'm not going to write that again. So now we have plus or minus 6. 6 over 3 is 2. I'm not going to write that again. And 6 over 9 is 3/2. So, I'm sorry, is 2/3, excuse me. And I already have that written, so I'm not going to write it down again. So all of these numbers are our possible rational zeros. So now we're going to use our graphing calculator. We have our reasonable rational zeros, and we need to find 2 of them. So in my graphing calculator, I'm going to enter in the function, and that is 9x to the 4th power plus 12x cubed minus 26x squared minus 11x plus 6. I'm going to press zoom 6 so I have a standard screen. All right, and I'm going to try to come up with some rational zeros. So I'm going to press second trace, go down to number 2, and I'm going to try to identify this first 0. Okay, so it looks like this is to the left. Enter. Press the right arrow one time. Enter, enter. Well, that is absolutely hideous. So I'm not going to be working with that because this is not a rational number, and we need it to be rational. So I'm going to press second trace, go to number 2, and try to find another rational 0. So here's my bug. It looks like to the left is down here. Enter. To the right is just above. Enter, enter. All right, negative 6 repeating, that is a rational number. So negative 6 repeating, that is going to be negative 2/3. So I have x equals negative 2/3, and that comes from the parentheses. Well, I would multiply 3 on both sides and then add 2, so that's 3x plus 2. If you need to see the work over here, what I would do is write x is equal to negative 2/3, multiply both sides by 3. We have 3x is equal to negative 2. Adding 2 to both sides, we have 3x plus 2 is equal to 0. So this represents our parentheses. Next, I'm going to find another rational 0. So I'm going to press second trace, go to number 2. All right, so here's to the left, I'm going to press enter. Here's to the right, I'm going to press enter and then enter again. All right, we have 3.3 repeating, which we know that that is 1/3. So x is equal to 1/3 is a rational 0. So if you need to see the work, this comes from the parentheses 3x minus 1. So what I'm going to do is take x equals 1/3 and multiply both sides by 3 to get 3x equals positive 1. I'm going to subtract 1 on both sides to make it equal 0. And so I end up with 3x minus 1 equals 0, and that is our parentheses. Cool. So now I'm going to use that negative 2/3 using my original problem, and I'm going to do synthetic division twice. So I'm going to write negative 2/3 inside of the box. And I'm going to write 9, 12, negative 26, negative 11, and 6. I'm going to bring down the 9. Negative 2/3 times 9, that's equal to negative 18 divided by 3, which is negative 6. 12 minus 6 is 6. Negative 2/3 times 6, that's 2 times 6, which is 12. Negative 12 divided by 3 is negative 4. Negative 26 minus 4 is negative 30. Negative 2 times negative 30 is 60, and 60 divided by 3 is 20. Negative 11 plus 20, that is equal to 9. Negative 2 times 9 is negative 18. Negative 18 divided by 3 is negative 6, and 6 minus 6 is 0. So what we have so far is 3x plus 2 times 9x cubed plus 6x squared minus 30x plus 9, and that's equal to 0. That's what I have so far. So now I'm going to use synthetic division again, using this 1/3. So I'm going to write 1/3 inside of the box, and I'm going to write out the coefficients of 9x cubed plus 6x squared minus 30x plus 9. So that's a 9, 6, negative 30, and a 9. I'm going to bring down the 9, and 1/3 times 9 is 3. 6 plus 3 is 9. 1/3 times 9 is 3. Negative 30 plus 3 is negative 27. 1/3 times negative 27 is negative 9, and 9 minus 9 is 0. So I still have the 3x plus 2. The 1/3 came from the parentheses 3x minus 1, and now I have 9x squared plus 9x minus 27 equals 0. So notice that 9x squared, 9x, and 27 are all divisible by 9. So I'm going to factor out a 9, and I still have a 3x plus 2 times a 3x minus 1, but now I have an x squared plus x minus 3 equals 0. So I need to figure out what two numbers multiply to equal negative 3, but together add to equal 1. And negative 3 and 1, they don't produce a 1. So this tells me this is not factorable. But no big deal. We know what to do when it comes to non-factorable quadratics. We would use the quadratic formula. So far this one is x equals negative 2/3. This parenthesis produces x equals 1/3, and this parenthesis produces x equals the opposite of b, which is negative 1, plus or minus the square root of b squared, so that's 1 squared, minus 4 times a, which is 1, times c, which is negative 3. This is all over 2 times a, which is 1. So now I have x is equal to negative 1 plus or minus the square root of some number divided by 2. So I'm going to put in 1 minus 4 times 1 times negative 3. And I end up with 13. So I have a total of 4 x-intercepts, and this is my answer. The only time that you have to, just to recap, the only time when you have to come up with 2 rational zeros is whenever you're dealing with a quartic. If you're dealing with a cubic, then you only need to find one reasonable rational zero. This is our last example, or last problem of this chapter. Congratulations, you made it. Here we go. It's just a quick story problem. So it says you are building a wooden square sandbox for a local playground. You want the volume of the box to be 16 cubic feet. You want the height of the box to be x, and the length of each side of the square base to be x plus 3. What are the dimensions? So I'm going to draw a quick picture of what this is supposed to look like. So here is my sandbox. Don't make fun of me too much. But here we go. This is my sandbox. My length and width, my base is a square. So this is going to be x plus 3 feet and x plus 3 feet. My height is x, and my volume is equal to 16 cubic feet. So I know that volume is equal to length times width times height. So I'm going to write 16 is equal to my length times my width times my height. So that's going to be x plus 3 times an x plus 3 times an x. Well, x plus 3 times x plus 3, that is just a perfect square trinomial. That's how it's going to turn out to be. So that's going to be x squared plus 6x plus 9. And I'm going to multiply that by x. So these two produced a perfect square trinomial. So I have 16 is equal to x cubed plus 6x squared plus 9x. I'm now going to bring the 16 over to the other side since I need to make it equal 0. So I have 0 is equal to x cubed plus 6x squared plus 9x minus 16. You can try to do factoring by grouping, but what you're going to find is that factoring by grouping does not work. So because it's only a cubic, you only need one reasonable rational 0. So I'm going to first identify what all of my possible rational zeros are. And so I'm going to use the number 16. And the factors of 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. Since it's my leading coefficient is a 1, you don't need to show that extra work to divide everything by 1. These are all of your possible rational zeros. Next, we need to identify a reasonable rational 0 using our graphing calculator. So in my graphing calculator, I'm going to enter in x cubed plus 6x squared plus 9x minus 16. I'm going to press zoom 6 so I can see my x-intercepts. Okay, so it only is showing one x-intercept, and so that second trace, I'm going to go down to number 2, and I'm going to identify what that is. And here's to the left, enter. Here's to the right, enter, enter. And that is 1, 0. So x equals 1, and it comes from the parenthesis x minus 1. So now I'm going to use synthetic division, and I'm going to put 1 inside, and I'm going to write 1, 6, 9, negative 16. I'm going to bring down the 1. 1 times 1 is 1, 6 plus 1 is 7, 1 times 7 is 7, 7 plus 9 is 16, 1 times 16 is 16, and negative 16 plus 16 is 0, which is exactly what I want. So now I have x minus 1 times x squared plus 7x plus 16 is equal to 0. So I have to figure out what two numbers multiply to equal 16, but together add to equal 7. 4 and 4 doesn't work, and 8 and 2 do not work, so this is not factorable. But no worries, we have the quadratic formula. So far I have x equals 1, and then I have x is equal to the opposite of b, which is negative 7, plus or minus the square root of 7 squared, minus 4 times 1 times 16. This is all over 2 times 1. So I have x is equal to negative 7 plus or minus the square root of a number divided by 2. And that number is going to be 7 squared minus 4 times 1 times 16. And that is equal to negative 15. And since whenever you take the square root of a negative number, it's imaginary, that means that this quadratic does not produce any real solutions, any real x-intercepts. So simply x equals 1 is our answer. And so since x equals 1 is our only x-intercept, we can now identify what our length, our width, and our height is. So my height, that was equal to x. So my height is equal to 1 foot. My width and length were the same, and that was x plus 3, and 1 plus 3 is 4. So each of those are 4 feet. And that is the end of this story problem. You might say, well, Miss Olivero, back at the beginning when we looked at the graph, there was only one x-intercept. Did we really have to show all of this work? And unfortunately, the answer is yes, because the I can statement is I can use synthetic division to solve real-world situations. So I am going to be looking for you guys to actually show all of this work. But fortunately, it's nothing compared to the work that we had for other problems. So fortunately, it was not that bad. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Or otherwise, I will talk to you next time.